Hi friends, this is GK Naidu. Today we are going to discuss about of the material properties, mechanical material properties. So before going to make the any project BTech final year projects or whatever the projects in our BTech level, so first we have to find out the let we know the mechanical material properties. So coming to the topic, so especially to focus on the mechanical properties. So while doing the projects, so mainly focusing on the only mechanical properties. When we have to enhance their mechanical properties, then we should get the more benefits of the particular objects, okay, and our components. So what are the mechanical properties are there? Coming to the first one, so that is the elasticity. So what is the mean of elasticity? Simply to say that, okay, which is regain its original shape and size by applying some external forces are removed. Okay, when we are applying some external force, then when we are removing that external force, then the object will regain its original shape and size. So that is the elasticity. And plasticity is also there. So plasticity means, so that is vice versa. That means when you are removing your external forces, then it doesn't get their original shape. Okay, that is the plasticity nature. Plasticity and elasticity. Okay, come to that. Next property is the stress. So what is the mean of stress? Simply to say that it is the ratio of uh, force to the unit area, force per unit area. So then we will also find out the stress, okay, by the help of particular this formula. And strains. So what is the use of strain and how to say that strain? So that means whatever the deformations are there in our object by giving the some external forces. So then we should also find out the strain values. That is the simply to say that original value minus our uh, enlarged, okay, enlarging of the component. So original component minus enlarging of the components. So that is the strain deformation, mainly focusing on the deformation. Next one, Hooke's law. So coming to the Hooke's law, that is already know that. So that is the relationship between the stress and strain. So what is the stress? What is the relationship is there between the stress and strain? Already we know that. That is the Hooke's law is there. So stress equals to K into strain. So that K is the our modulus of elasticity. Modulus of elasticity. So we have to find out the modulus of elasticity when we should know the stress value and strain value of the our particular object. So that is also very important property in our mechanical. And some stress strain curve is also there. So let me see that in our next. Okay. And toughness. So coming to the toughness point of view, simply to say that it is the ability of material to absorb the energy and undergo the plastic deformation and undergo the some plastic deformation without undergoing of the fracturing before going to fracture. So how much of plastic deformation is there? Okay, let me find out that in our toughness. So how we are find out the toughness? Let you know that. So how to find the toughness value in our BTech level experiments. So there is a some experiments are there for find out of the toughness value. That is the CHARP and the IJOT test are there. So while we are taking the particular material or object, okay, so then simply put it on the particular in our IJOT and CHARP test. So then simply to find out the toughness value. So that means how much of load it will bearing. Okay, while we are applying that particular load, sudden load. So that is the sudden load. While we are applying the sudden load, how much of strength it is there for particular materials. Let me find out in our toughness property and ductility. So ductility point of view, it is also the ability of material to undergo the plastic deformation before rupturing. Before rupturing. So So this point of view, this property are known as also ductile materials, especially ductile materials. So what is the good ductile material is capable of being drawn into wires. So ductile nature. Ductility means, for example, copper. Let you know the copper. So when you are heating the some copper and when you are applying the some uh, tensile strength, okay, so then that is also able to, okay, making the some deep drawing process. That means wires. We should also convert it into the in some types of wires. So that is also able. So that all the materials are will be able to make the particular process, that is not possible. Only few property and few metals are only able to make the particular ductility nature. That is the copper, aluminum, and some of the steels. And okay, so those are the silver. So those are the only some metals are having the some ductility nature. So before rupturing, so how much of plastic deformation is there while applying the some external force? So that is the ductile nature. And next one is the hardness. So hardness means coming to this point of view. So the capacity of the substance to withstand the long-term shape change brought on the some external stress. So simply to say that this is a scratch hardness, indentation hardness, and the rebound hardness, and the different types of hardnesses are there. So hardness is how we are find out the hardness value. Is there any experiments are going on for find out the hardness? What are the experiments are conducted for find out the hardness value in our SM lab? So those are the experiments are there. Brinell hardness tester and Rockwell hardness tester. So while we are okay, when we have to find out the hardness of the particular material, so then simply to make the okay particular project, so particular experiment, then simply to find out those values. So that is the hardness nature. You should also find out the hardness nature by the scratch indentation. Okay, scratch hardness and indentation hardness. That means surface strength mainly. And now these are the three types of resistance are there in our. So and coming to the next one, strength. So how we are defining the strength here? So simply to say that it is the ability to resist the deformation, ability of deformation or disintegration in the face of the loads or external forces. So how we are find out the strength in our experiment generally in our SM lab? So that is happen by the help of UTM. So that is the tensile strength and the compressive strengths are there. Okay. So that is the we should also find out the tensile strength values and compressive strength values while we are taking the our billet, while we are taking the some billets. And next one is the brittleness. So brittleness nature. So coming to the brittleness point of view, a material is brittleness. That means how easily it fractures under the influence of the under the influence of some force or load. So that is the brittle nature. So let me take that. Let you say the any some examples brittle nature materials. Brittle nature materials. Tell me some materials. What type of materials are having the brittle nature? That is the simply to say that our general and common example is the glass. Glass is a brittle nature, and cast iron is also a brittle nature. Cast iron also brittle nature. So when we are having the particular brittle nature, so that means it doesn't also it doesn't okay it doesn't lost the okay sorry it may also lost the some material properties. Okay, when the component when the material is having the some brittle nature, so we have to overcome that brittle nature in our materials. So let me try to enhance the we have to reduce the brittle nature of our materials. And coming to the next one, malleability. So malleability means simply to say that here the ability of material to be rolled or hammered into this sheet. Okay, so while we are applying the some rolling or hammering of the particular sheet, so then that is saying as a malleability. Okay, what when we are doing the particular job, so that is the hammer or rolling, hammering or rolling. So then this the mechanical quality. Okay, this mechanical quality is a component of material's plasticity and the temperature affects material's malleability. So that means when that particular nature is there while we are doing the some hammering, so is that material is able to withstand, okay, or not? Let me check of our particular material. So when it is having the good nature, so that means, for example, let me take the type of nature is having the aluminum. So aluminum is having the some malleability. That means that's why we should also mostly prefer to preparing of the bowls. Aluminum is best material for malleable. So that means malleability nature is there. That's why simply to convert it into the number of bowls, kitchen bowls. Okay. So that is the malleability nature. Okay. And wear resistant. Next one is the wear resistance. So wear resistance is also the type of a material capacity to endure the impact of the two materials, okay, scoring against one another. So that is the wear resistance. Is the material is having the wear resistant or not? Okay, so that is also one of the good and important okay mechanical property in our wear resistance. So that means how much of wear rate is there while running of the particular 1 year of the particular component. So let me take to that. For example, if you want to, if you will buy a chappals, so then so after okay usage of the 1 year, so then definitely that particular sandals are going to okay some wearing. So after okay if the wearing rate is high, then simply to change the particular sandals. So similarly to our materials also, so when you are buying or when you are procuring the any one component, so the materials are some wearing resistance is high, that particular component, then definitely we should also replace the particular components. So uh, before going to procure that one, so let me check that is that material is having the good wear resistant or not. Okay, so let me check on that. So those are the mechanical properties. And now here there are some types of properties are here. So that means that overall properties, these are the. So those are the acoustic properties, atomic properties, chemical properties, electrical properties, and environment properties, physical properties, manufacturing properties, magnetic properties, optical properties. Number of properties are there. So only we have focusing on the only mechanical properties. So when we should know more knowledge on the mechanical properties, then whatever the projects we do in our BTech level or okay in our MTech or PG levels, so then that is very much helpful to us, okay, in our projects point of view. So coming to that, this is the stress strain curve. Already we know that. So let us take the steel point of view. So this is a steel. Okay, let me take the steel material. So then what type of curve will be generated? Okay, in our this stress strain curve. So that is the, so while we are look out the particular this curve, so that is the stress and strain curve. So up to some load value, up to some load, so that is the A point is there, proportional limit, up to that proportional limit. Okay, so it doesn't okay it does not suffer that okay more, it doesn't suffer the particular material more up to our proportional limit. So that means when you are leaving the particular load of that material, so then simply to regain the their simply to regain the their original shape up to our elastic limit, up to our elastic limit. That means so elastic limit. So for example, if you are hammering the some steel okay, steel rectangular block, for example. So when you are hammering the particular rectangular block of the steel, so then that is having the some elastic limit. So up to that elastic limit, how many times you have hammered or how many times you have hit it. Okay. So then it doesn't suffer. It doesn't change their shape. Why? Because within the elastic limit. But after the elastic limit, it may also goes to the our plastic deformation is there. So after when you are overcome that elastic limit level by the application of your load, so then it may also change their shape. So this is the plastic deformation. So up to this place. So if your load value is overcome to the in your plastic deformation, that means this limit also plastic deformation limit also. So then that load is also okay. That means you are applying the high load. So then after some time, okay, if the load is not bearing to the particular material, then the material is going to fracture. So these all the things will happen in our particular stress strain curve. So up to okay, up to which load it may also resist, and up to which load it may also transform their shape, and up to where it is going to be fractured. So that is those things will representing in our stress strain curve especially. So these are the basic details. Uh, let we know the okay. Let we know before going to start the our BTech level projects. Thank you, guys.